Hello and a warm welcome to this short introduction session on AI literacy for environmental and social professionals. In our field, the challenges are growing more complex and the data volumes are overwhelming. This preview is designed to demystify artificial intelligence and show you exactly why it's becoming essential in our work. Today, we'll cover the three objectives: what AI actually is, with clear explanations in plain language. You know me, no technical jargon or confusing terminology. We're going to cover why it matters right now, talking about the current trends in AI adoption and environmental and social work. We will also talk about real E&S applications. This course, the full version, is heavily reliant on the workbook and real-world examples and experimentation with different AI tools. This preview only scratches the surface. The full course includes comprehensive case studies, risk assessment frameworks, practical workflows that you can implement immediately. Let's clarify the terminology that often gets mixed up when we talk about AI. Understanding these distinctions will help you evaluate which tool is right for you or your projects. You can break down the AI into three main concepts: automation, machine learning, and deep learning. Automation is the simplest level. It follows fixed pre-programmed rules like a calculator performing the same mathematical operations every time. For E&S, this is like automatically flagging permit applications that exceeded emissions thresholds. The machine learning is where the system finds patterns in data without explicit programming. An example is software that learns to classify different types of land cover from satellite images. In E&S, this identifies deforestation patterns across different regions and seasons. Deep learning is a multi-layered neural network for complex pattern recognition. This enables advanced systems to identify individual species from drone footage, for example. In E&S, it might mean monitoring wildlife populations and behavior changes in protected areas. To make it simpler, think of AI like cooking. It helps to understand the different approaches through something very familiar. Following the recipe equals automation. Following the exact steps every time, no variation. If you mix something, it will always turn into the same thing. That's automation. Now, if you're learning from experience and adapting based on what works, what doesn't, if it means adding a little bit more salt, for example, that's your chef experimentation. That's exactly machine learning. And now, when we look at a team of expert chefs who have different layers of experience and incredible expertise working together to create an incredible meal, that's deep learning. Just as different cooking approaches suit different meals, different AI approaches suit different environmental and social challenges. You're already using AI more than you even realize. These everyday tools demonstrate the same underlying principles that power environmental and social applications. Think about Google Translate that processes multiple languages instantly, understanding the context and the nuance across different cultures and regions. Also think of your Netflix recommendations, which basically following the patterns and preferences and suggesting shows based on what you previously enjoyed. Or some voice assistants such as Siri or Alexa that understand your speech, process the request, and learn from your interaction patterns. The same logic that powers these consumer tools is already being applied to environmental monitoring, social impact assessment, and sustainability reporting. Why is AI essential for E&S professionals working at scale right now? There are three main forces that are converging to drive this change. The number one is the explosion of data. Whether we're talking about satellite imagery, sensory networks, community feedback, regulatory databases, the information dump that is generated is a lot more than what human analysts can process manually. AI helps us extract actionable insights from this wealth of data. Computing power also became a lot more accessible and affordable. Cloud computing has made powerful AI tools affordable for organizations of all sizes. What once required a massive investment of infrastructure is now available through a simple subscription service. There's also the demand for faster insights and more rapid response. Whether it's the stakeholders, your shareholders, the regulators, and communities, they all expect rapid responses to environmental and social challenges. AI can accelerate the analysis, the monitoring, and the reporting processes significantly. In the main course, we have a lot more examples, but for this one, I picked these two examples of how AI is already transforming environmental and social work. These represent just the tip of the iceberg. The AI algorithms analyze satellite imagery to identify forest clearing within hours of occurrence. This technology can monitor a large surface area with different locations simultaneously. It can distinguish between natural and human-caused changes, alert relevant authorities or NGOs automatically if there's change in the vegetation or if there's activities on the site, and it can track the restoration efforts over time. The second example is something that's also already happening: natural language processing tools that sort and analyze thousands of community comments, maybe even perform a sentiment analysis to identify key themes and how the people approach the project. In this process, the AI system processes the feedback that can be in many different languages, groups similar concerns automatically, flags the urgent and the sensitive issues, and generates the summary reports for decision makers. The full course explores applications in biodiversity monitoring, climate risk assessments, disaster risk assessments, social impact evaluation, and a lot more, with the workbook bringing you very detailed, thought-provoking, and reflective questions on your AI adoption journey. Understanding the learning process helps you evaluate AI tools and set realistic expectations for your projects. The process involves 4 stages: understanding the training data input, the pattern recognition, the model creation, and the prediction and application. Each AI system is trained on a large data set that is usually labeled data, including images, text, measurements, along with the attached labels and categories or correct answers. Later on, the system identifies these patterns and will be able to make new predictions on a new training data set. Similarly, how children learn about the world and how they learn to distinguish between different objects, identifying cats and dogs, and later on identifying the different dog species that have distinctly different features. In the model creation step, the patterns become these neural networks or mathematical models or the algorithms, and they can be used on previously unseen data. So that's the testing data set. Once the algorithm is ready to deploy on new data sets for testing and then live deployment, that's when you get the prediction or the analysis. Let's test your understanding with a quick knowledge check based on a practical scenario. Your team has collected 100 community consultation surveys in 3 different languages from residents affected by a proposed development project. You need to identify the common themes and concerns quickly. Which AI tool is the most appropriate for this task and why? The correct answer is A, natural language processing. Natural language processing tools excel at processing text in multiple languages, identifying themes, and categorizing responses. This course has 6 modules, from the foundations of AI, explaining what AI really is, what are the different types and functionalities. In module 2, we look inside the black box and see the data training and how it learns from examples. In module 3, we're looking at the practical applications in biodiversity, land use, climate and risk prediction, stakeholder engagement, and compliance. Module 4 covers risks, biases, and ethics, identifying the sources of data bias, warning against fake confidence of polished AI outputs, and thinking about the human accountability aspect. In Module 5, we're covering safe AI use, and you'll be equipped with the essential validation checklist and the framework for organizational governance. And Module 6 concludes with looking at the future trends and what to watch, covering the rise of open source AI, policy and planning, and how organizations are getting ready to implement and adopt AI systems. The course also includes an interactive workbook with hands-on scenarios like resettlement mapping, climate risk modeling, stakeholder engagement analytics, using real data sets and real examples. Before we wrap up, let's consolidate the key takeaways from this preview session. We talked about the basic AI terminology and the difference between automation, machine learning, and deep learning. We covered what led to AI being so important today through the explosion of data and just the timeliness of making E&S work and other type of work more efficient in general. And then I brought you some examples that are similar to the ones that are included in a workbook. And this is something I say many times during the course. AI is a partner, a researcher, a tool, an extension of a human expert, and not a decision maker or a senior expert. Your professional judgment is what makes AI work efficiently in environmental and social context. Join the full course to gain confidence, learn how to maintain ethical standards, and connect with a community of forward-thinking E&S professionals. I strongly encourage you to secure your place and start your AI literacy journey today to transform how you approach environmental and social challenges. Thank you for joining this preview session. Your future self will thank you for taking this important step towards AI literacy in environmental and social work.